Welcome back to your learning journey. In this video, we're diving into SQL Basics Part 5, and this one is a bit more advanced. If you've been following the series, you already know the fundamentals. Now it's time to take your SQL skills to the next level. In this part, we'll explore more powerful concepts that help you write efficient queries, handle complex data, and improve performance.
Let's understand SQL subqueries. A subquery is a query nested inside another query in SQL. It is used to fetch data that will be used by the main query as a condition to filter or manipulate the result. Now, let's look at some key points. A subquery is also called an inner query or nested query. It always executes before the main query. The result of the subquery is used by the outer query, and it can be used with select, insert, update, or delete statements. Next, let's understand the syntax. We start with select column name from table name. Then we use the where clause with a subquery. Where column name equals, open bracket, select column name from another table where condition, close bracket. This is how a subquery works, by embedding one query inside another to make your SQL more powerful and dynamic. That's the basics of SQL subqueries. Let's move on to examples in the next part. Let's explore the different types of subqueries in SQL. First, we have the single row subquery. This type of subquery returns only one value. Here's an example. We select the name and salary from the employees table, where the salary is equal to the maximum salary from the same table. In simple terms, this query selects the employee with the highest salary. Next, we have the multiple row subquery. This type returns multiple rows of data. In this example, we select employee names from the employees table, where the department ID matches any department ID from the departments table located in Bangalore. So this query retrieves employees working in the Bangalore location. Finally, we have the correlated subquery. This type uses each row of the outer query to execute the subquery. Here's how it works. We select employee names and salaries where the employee's salary is greater than the average salary of their own department. In other words, it identifies employees earning above the average salary within their department. And that's a quick overview of the three main types of subqueries: single row, multiple row, and correlated subqueries.
Let's understand a powerful SQL concept. Subquery in the from clause. Here, we are selecting employee ID along with all average salary. Now, take a closer look at this part. We are using a subquery inside the from clause. Inside the subquery, we select employee ID and salary, and then calculate the average salary using a window function. Average of salary over as all average salary. This means the average salary is calculated across all rows, and the same value is assigned to every record. We are pulling this data from the employee salary table and giving the subquery an alias, A. Then, in the outer query, we simply select from this result and order it using order by a.employeeID. Now, look at the output. Each employee ID, including null, has the same average salary value, 47,909. This approach is very useful when you want to combine row-level data with overall aggregated values. And the best part? It's an efficient query that improves performance while keeping your logic clean and readable. That's why subqueries with window functions are great for both efficiency and speed. SQL subquery and window functions, made simple. Let's understand subquery in where clause with simple and practical examples. Subqueries help you filter data using nested queries, making your SQL more powerful and dynamic. Let's take a look at subqueries in where. We're selecting employee ID, job title, and salary from the employee salary table. But here's the key part. We are filtering using a subquery. Here, we are filtering using a subquery. where employee ID in select employee ID from employee demographics, where age is greater than 30. So what's happening? First, the inner query runs. It fetches all employee IDs where age is greater than 30. Then the outer query uses those results to filter matching employees from employee salary. This is a perfect example of filtering by nested data. Again, we select employee ID, job title, and salary from employee salary. This time, we filter based on salary, where salary in select max salary from employee salary. Here's what happens. The subquery calculates the maximum salary in the table, then the outer query returns only the employees who have that max salary. This helps identify top earners instantly. Key concepts covered. Filtering using nested subqueries, working with cross-table queries, using aggregate functions like max function, and improving query performance with efficient filtering. Subqueries in the where clause are extremely useful when you need to compare, filter, or extract data dynamically. In this video, we'll dive into an essential SQL topic that can drastically change your query speed: subquery versus partition by. Let's look at a common scenario. Say we have an employee salary table, and we want to find the overall average salary for all employees, but keep it alongside the individual employee records. On the left, we have the classic approach, subquery in select. The code looks like this. Select employee ID, salary, select average salary from employee salary as all average salary from employee salary. This query works, but it's often inefficient. For every single row returned by the main query, the database engine has to execute that whole inner subquery again to calculate the average. If your table has millions of rows, that's millions of subquery executions. Now, let's look on the right at a modern and much faster solution with partition by. This uses window functions. The code looks cleaner. Select employee ID, salary, average salary over as all average salary from employee salary. Notice the over parentheses clause. This tells SQL to perform an aggregation but across a set of rows, the window, while keeping the row-level data. The key is how it works under the hood. The database calculates the average salary once and then just appends that single value to every row. This avoids that slow row-by-row recalculation, which is a massive performance boost. Here's the resulting data you would get with either query: a simple table with employee ID, salary, and a column for the all average salary. Notice how all average salary is the same value for every single row. The bottom line? For efficiency, it's almost always a better idea to use partition by and window functions for this kind of calculation. As this speed up queries tip reminds us, mastering this technique will make your queries faster and your work more efficient.